Namaskar friends, welcome to the third week of discussion of our course on product design using value engineering. We have already completed 2 weeks of discussion and I sincerely hope and sincerely wish that you may have enjoyed the discussion. At least some value addition, as the name of the course is product design using value engineering. So, value is an important part for our course. So, I sincerely believe that some value addition must have taken place in your understanding about the concept of value engineering and analysis. As you know that our target is to apply the concept of value engineering analysis into the product design process. We would hereon like to focus more on the practical applicability of the concepts using very simple examples. If you remember in the previous session, that was session number 10, we have covered 2 examples. We have taken a fast diagram for a pencil and tried to see that how the fast diagram can help us to design the pencil in a better way depending upon the needs and requirements of the customers who are going to use that product, and the product taken was a pencil. Another example in the same session, that is session number 10, we have taken related to the design of a overhead projector. We have seen that the overhead projector is very well designed. There are so many different parts, components, sub-assemblies which are making up the overhead projector. But once we draw a fast diagram, we are able to identify the key areas where there is a poor value existing in the design. So, that poor value, once we are able to identify, we will be able to eliminate that poor value with better alternatives using our creativity, using our technical know-how in terms of materials, manufacturing, design guidelines. We will be able to eliminate that poor value with a better value option, and that is what is the target for us in value engineering. So, today also we will try to take an example and try to understand that how the functional cost relationship actually works. So, basically if we see that most of the products, if we try to understand functional value in case of any product, if you will see that the basic function will account for a significant amount of cost, but that is not that significant that it must be taken as it is. What I mean to say is, for example, if we take an example of the pencil again and we write the basic functions of the pencil, we write the secondary functions of the pencil. So, we can say that the cost contribution between the basic and the secondary functions we have to understand, because the cost that we are locking with the primary function may not be all the cost that we are charging the customer for. So, we have to see that what is the cost distribution, what is the basic or the primary function of the product and how much cost must be associated with that. And what are the secondary functions? Can we eliminate some of the secondary functions to save on the cost? Now, let us quickly see one example. We have already taken example of a pencil which each one of us is using. So, we can see that these are the components of the pencil or the cost components. We can say there is lead, then we have a wood or protective coating, we have metal cap, we are assuming a pencil with a eraser at the end, shaping of the wood for making it giving it a smooth finish or giving it a proper grip. So, we can see that there are different, then sometimes we print, for example, save trees or save environment. So, we have that various functions for each of these. So, lead is make marks, then wood is protect lead, metal cap to hold the eraser, eraser is to remove the marks, shaping of wood to provide the grip, printing is to display the information. Now, if you remember in the previous session for the pencil we have taken making of marks is one of the basic functions for the product and the cost is only 50 paisa, whereas the price of the pencil is rupees 5. So, we can see that only 10% contribution is of the part or the component which is contributing to the basic function of the product, and the 90% we can say is the profit is suppose 1.5 rupees, the total cost is 5 rupees. So, we can see suppose I am paying rupees 5 to buy a pencil, the basic function can be achieved with a lead, that is 50 paisa only. Now, we have to see that how we can establish this functional cost relationship, what are the essential secondary functions that are required to achieve this basic function. So, maybe sometimes we may not like to hold the lead directly, a coating is essential or a covering of lead is essential, whether it has to be a wooden covering or it has to be a plastic covering, or what are the alternative designs that can be taken into account. So, this all is basically a functional cost relationship of a product. We would like to find out that what is the percentage contribution of the basic function in the overall cost of the product or the overall price that we are charging from the customer, or are there some secondary functions which we can plan to eliminate. So, with this we have taken an example of a research article which was published by Mr. Chaugule Mahadev in the International Journal of Innovative Research in Science and Engineering. So, this is just an example that we have taken. The example is of a divan. Now, this is a divan which normally we use in our houses. These are the legs, this is the side strip, this is again a short side strip, this is the, you can say, bed or maybe the platform for the customer. Now, we can see that this design, what we have to do quickly, now let us see that how we will be able to solve this problem. What we need to do? We need to blast this product into the individual components or the individual parts, and then write down the verb noun definition for each and every part, and then establish the cost for each and every part, and finally see that which all parts are contributing to the primary function of the product, which all parts are contributing to the secondary function of the product, what are the parts which can be eliminated, what are the alternative designs that are available with us, and how those designs can help us to get a better product at a reasonable cost. So, first thing is functional analysis worksheet is prepared for the different parts of the product. Already I have told this, and we will see for divan what is the functional analysis worksheet. Functional evaluation is done, that is we say that what is the basic function being achieved by that part, what is the secondary function being achieved by that part, that is the functional evaluation. Then the numerical evaluation sheet is prepared where we write the cost for each and every part or the sub component. Then comes the creativity. Already we have taken a session on creativity. Here we already know now this is the one, this is the existing product, these are the various parts of the product, this is the cost of each and every product. Now we will try to use our creative skills to find out the alternatives. Alternatives may be in terms of materials or alternate materials, it can be in terms of alternate manufacturing processes, it can be in terms of alternate designs of the product, maybe we change the overall look of the product. So, we would like to create a sheet where we would like to write all the alternatives. Then selection of the alternative is done through the decision matrix. Now, there can be number of approaches that you can use for finding out the best alternative among the existing alternatives. You may be having 5 different alternatives, out of that you may like to select the best alternative which is giving you the performance at the minimum cost. Then we will report our finding and recommend our solution that we have found out or the best alternative, and finally the conclusion. So, this is the overall structure of this article, and quickly we would like to take the most important things. So, here we can see we have a steel frame which is the basic assembly. Based on this steel frame the overall assembly will be done. Bed top, that I have told in the image, the platform on which the customer is going to sleep. Then side strip is there, side strip, long side strips are there, then shorter side strips are there, then the leg strips are there, and you can see the verb and the noun definition for each and every part has been written. For example, if we say bed top holds the material, provide the surface for sleeping, improve the appearance. So, we have basic and the secondary function. Similarly, for each part we can do the functional evaluation as basic and secondary, and for assembly also we can do the functional classification as basic and secondary. So what are the basic functions? So we can see that these are the parts which are satisfying the basic function. Steel frame, yes, it has got a basic function. Bed top also has got a basic function. Side strip has also got a basic function. Side strip short also has a got basic function, and leg strip has also got a basic function. So all these parts whatever are listed out here for the divan have got the basic functions. But you can see from the functional evaluation point of view that there are number of secondary functions also which can be studied, and these can be tried to be eliminated, or these can be tried to combine with each other, so that we are now able to develop a better product. So this is the first stage, that is the functional analysis of the divan. Then for each, now we have seen the title of our session is functional cost analysis. Now we have to from here on focus on the cost component also. So you can see the cost component here. So we have 5 components: steel frame, bed top, side strip long, side strip short, leg strip, and then the quantity is given for each one of these, and the costing is given, and the overall cost is mentioned here. So we can see that the distribution of the cost, that the steel frame is contributing to the maximum, that is rupees 495, then is the bed top, that is the divan top, 465, and similarly we can see the cost for each and every component. Now 2 things are known to us. We have done the functional analysis. For each and every part we know that what are the functions, and within the functions also we know what are the basic functions being achieved, what are the secondary functions being achieved, and then for each component we know what is the cost. Now we can find out the value gap, that is that what can be the minimum cost with which the functions can be achieved. So that is given here. So we can see that once we do this functional evaluation of the different parts, we can see hold the assembly, the weight is also given, percentage cost contribution is also given. So what we do? We do A in context of B, C, D and E. So if we go back, you can see we have named these parts as A, B, C, D and E. So in our analysis part we have tried to relate. So 3 basically wherever we have written, it means that A and B are strongly dependent, so major performance. So A and B. So what is A is steel frame and B is bed top. So they are interrelated in a better manner, that is they are influencing a major performance, and minor performance is 1. So we can see here C 1. So we can see A and E, so it is 1. So performance is 1 only, which is lesser. So 3 means higher relationship, 1 means lower relationship. We are in this direction, we are moving A, B, C, D and E. So accordingly we can see that D, how it is in relation to C, how is performance, whether it is a major performance, medium performance or minor performance. So we can see the contribution of cost also in the overall product. So steel frame maximum cost, then bed top next to that, and the leg strips are having the minimum contribution to the cost. So here also we can get the rankings also. A is the most important part because 3, 3, 3 and 3, so 12, and whereas D has, or the D is our side strip which has got a less contribution, and E has also got a lesser contribution. So what we have found out here is that from the cost point of view also steel frame is contributing more. From this decision matrix also A is our steel frame is an important part of our product. So we have now focused on that what are the lesser important parts, what are the more important parts, what is their contribution, how they are going to influence the functional or the performance or the functional performance of the other parts. So main guiding principle or the guiding part here or the main important part here is our is our the steel frame. So now we can decide that what we need to do, and here we can see how this information is represented here, that is the weight contribution and the cost contribution. Now by now we have tried to understand the overall summary. Now what is the overall summary? We now know that which part is contributing more cost, which part is contributing more weight to the product, because in case of a divan, one of the criteria can be that it must be light in weight, or we can put the rollers or the tires just below the forelegs so that we can easily move it or make it portable from one place to another place. But once we put the wheels, we have to ensure the stability also. Once we want to place it at a particular location, we have to ensure that it is hinged or it is fastened at a particular place so that it does not move when a person is climbing on the divan. So there are additional functional requirements that arise once we make it light in weight, as well as we make it portable by putting rollers under the legs. So there are certain advantages of making it portable and mobile, but then in the creative phase we will try to find out how we can reduce the weight of our divan. That can be one of the major criteria. How we can achieve the performance or the basic function of providing a comfortable bed or a comfortable resting place for the customer at a reasonable or the minimum cost. So these are the things with which we go to the creative phase and try to find out that what can be the better or the alternative designs which can help us to get the product, the fully functional product, but at a reasonable cost. So the following ideas were generated during the design phase. First is make the design simpler. That is very important. Use the wheels for movement, already I have told. Make it in powder coating, maybe to make it rust free or corrosion resistant. Reduce the thickness of the board, maybe that may also add up to making it lightweight. Use the waste pieces of required size in some places to focus on the cost component of our product. Reduce the size of the board in some places, it is not same at some places. So we can try to reduce maybe side strips, if they are not carrying too much of load, we can try to reduce the thickness of the side strips. Reduce the gauge of the pipe, so we can try to reduce the gauge of the pipe, but without compromising the performance or the we can say effectiveness and efficiency of the product. We can think of reducing the gauge of the pipe, but that must not influence the performance of our product. So these are some of the creative ideas, and if we give the similar problem to all of you, you can also come up with n number of additional ideas which can help us to make the product better. Now we can see here, this is the value gap which has been calculated. Now we can see the assembly. The first part or the component, that is A, the basic purpose is to hold the assembly. Now what is the tentative alternative? It can be mild steel, because currently if we go back and try to see, we have a steel frame A and the basic function is to hold the assembly. So that is the basic function. So the same thing, it can be made in existing cost is 495. If we make it in mild steel, it can be 390, and the value gap is 105 and the ranking is 1. So first alternative that we can try is changing the material of the frame from the existing steel to mild steel, and the basic function is hold the assembly. Then the bed surface or the bed top, provide the surface. Current cost is 465. This is a board, material is board. We can get that function at 400 rupees and the value gap is 65. Similarly, for the other parts or components of the divan, we can see that what is the existing cost, what can be the tentative alternatives, and finally what can be the value gap. So we can see that the estimated cost is 1180 rupees and the current cost is 1526. So definitely there is a difference between the two, and the difference being 346.00. So which means that the current design, without compromising the performance of the product, has the potential to save certain cost, certain elements of cost by changing to alternative materials, changing to alternative designs, changing to thickness of the gauge. So, changing the maybe basically we say a change can always lead to better results. So, here we can see again this is the same information represented in the form of a bar. So, this blue tower is showing the existing cost, the red one is showing the estimated cost, and the green one is showing the value gap. So, we can see for each of the sub parts we have a value gap. So, we can try to focus on this value gap, try to experiment with the alternatives, try to check the performance of the product with the alternative materials, alternative thickness of the board, alternative gauge of the pipe, and try to see whether the product is performing to the satisfaction, it is able to pass all the desired tests that are required before launching the product in the market, whether it is able to get all the certificates that are required to launch the product in the market, whether it is able to pass the tests and the guidelines specified for similar type of products. So, by changing all these materials and gauge of the pipe, we have to find out that whether the material is able to perform up to the desired level of performance or not. So, without compromising on the effectiveness, efficiency, performance, reliability, durability, dependability of the product, if we are able to bring on these changes, the case study is showing that we will be able to save some money. Now, here evaluation phase, what are the parameters here? The parameters decided for this case study is as published in the research article are rigidity, it must be lightweight, durable, and the appearance must be good. So, these are the 4 parameters. So, weightage of the parameters is found out. So, we can see that out of these A, B, C and D parameters, again A, B, C and D parameter, B, C and D, we find out that the final score is 7, 4, 1 and 1, which means A, that is rigidity, is one of the prime parameters, and 4 is B, that is lightweight. So, the main parameters, the durability is coming third and the appearance is coming also again at the same ranking, but the main 2 important parameters. Why appearance? Because in most of the cases you will see that divan will be covered with a bed sheet or the mattress. So, mattress will be covering the divan with a bed sheet. So, may not be the appearance may not be that significant parameter which can influence our decision. Also, the durability definitely is, but as it is related to rigidity, because if it is rigid it will be better, so it will be durable also. So, we can say as per this case study or within this domain, we can say rigidity and lightweight are 2 important parameters. It is not important to debate on the rigidity and durability, but it is important to understand the process that how we can analyze our product. So, we can see out of the 2, now how we can achieve this? We can have alternative 1, change the gauge of the material, that is the pipe. So, we can try to use a different gauge pipe for making the product or the assembly. Now, as an alternative, reduce the thickness of the board wherever required. So, based on the 4 parameters that we have identified, we finally decided 2 alternatives: change the gauge of the material and reduce the thickness of the board. Now, here we can see the evaluation matrix for the existing and the proposed. This is the ranking 5, 4, 3, 2, 1, 5 is excellent, 1 is poor. So, we can see here parameters weightage. So, rigidity, lightweight, durability and appearance. So, this is the ranking 7, 4, 1 and 1, which we have found out in the previous slide. If you can go back to the previous slide, and 7, 4, 1 and 1, 7, 4, 1 and 1. So, existing we are giving the ranking, rigidity is 4, lightweight is 3 ranking. So, this ranking is based on this scale. 5 is excellent, 1 is poor. So, existing is 4 in terms of rigidity, 3 in terms of lightweight, 3 in terms of durability and 3 in terms of appearance. So alternative 1 again 4 4, it is lightweight for alternative 1. And what is alternative 1? Change the thickness of the gauge. So you can see what is alternative 1, change the gauge of the material. So again it is lightweight because the gauge is going to change. So the pipe we are going to use is different, so it will make it lightweight. And this is here 3 and 3. So the overall ranking, if you add this is going to come at 50. So alternative 2 again 4 5 3 and 3. So this is 54. So we say that the overall ranking for parameter weightage alternative, these are the parameters in this direction, this is the weightage, and these are the alternatives. So we get that for alternative 2 we get a higher score. So therefore we can see that cost benefit matrix, steel frame change to gauge, then plywood, hardware, frame printing, other. So this is the existing design, this is alternative 1 if we select, and this is with alternative 2. So if we select alternative 1, 1303 is the cost. If we change alternative 2, change to alternative 2, 1227. So even if we see that if we select alternative 2, that is use a board with lesser thickness, our cost is going to reduce, and we are able to still focus on two important parameters, that is lightweight and the rigidity. So we are not compromising on the rigidity of our product, we are not compromising on the weight is not increasing, in fact it is reducing, which is better for the functional requirement of our product. So if with this we can see that if we implement this, the samples as per alternative 1 and 2 were manufactured and tested with the customer, reports were found to be satisfactory for both alternatives. In alternative 1 and alternative 2, weight reduction was found with cost reduction. The proposal was put to the management finance department for approval. So you can see that by changing the material and analyzing the cost implications of those two alternatives, that is changing the pipe and changing the board, the performance was not compromised, the performance was better, the weight of the product also reduced, that is the one, and the customers were also happy to have this product. So we can say, or we can conclude that value engineering was used for cost reduction without change in the product design and its value. More important is that the value increased by as well as the cost also reduced. The total saving incurred per product by the implementation of the above recommendations was 19 point approximately 20% for alternative 2 and 15% for alternative 1. So we can see that without compromising the performance of the product, the authors were able to save 20% cost in one alternative and 15% cost in another alternative. In future, furniture product design can be modified so that the value of the product can be enhanced. Other industrial engineering techniques can be used for further improvement in the product. So we can conclude that if we do a systematic analysis of the functions of the product, we focus on the cost component of each and every part of the product, we will certainly be able to find out alternatives through the creativity, or when we implement a creative thinking approach in finding out the alternatives for satisfying the intended function of each and every part of the product and see its implication on the cost. Obviously we will be able to improve the value of the product by satisfying the desired function at a reasonable or the minimal cost. So this case study of Diwan has established that if we focus on each and every component and try to link it with the cost of each and every component and find out the alternative ways which for achieving the desired function of each and every component, we will be able to propose a new design which will give us better performance. So with this we come to the end of today's session. I have already shown the reference from where this case study was taken. So we are thankful to the author who has published this article, which has helped us to understand the cost functional analysis or the functional cost analysis of a specific product, in this case that is a Diwan. We will try to do further a study or a case study on functional cost evaluation of a different product in our next session. Thank you.